Good evening and welcome to today's class. What we are going to be doing today is partially solving questions concerning Math 101, or let me say, for those of you writing JAMB and WAEC, you're going to be needing this, you understand? So if you have joined the live already, what you have to do is just to drop your location where you're watching from, you understand? So like I said, we're going to be solving questions today. We are going to be making questions more easier, you understand? I have 5 questions here with me that we're going to be solving in today's live, you understand? So let's go. So I won't waste much of your time. Let's go into the live. So what I want from you is your ultimate focus. I want you to know that making maths more simpler here, understand? Let's go. My first question is, it says simplify So this is my first question, and it says simplify the cube root of 729 v raised to the power of minus 6, or in a bracket 1 over what? 2. So I hope you guys can hear me and can also see what I'm writing, you understand? So let's go. I will say what? My solution. So whenever you see a question like this, first of all, you need to understand that this question is mainly from what? Indices. You understand? This is an indices question. So what we are going to be doing here is that we are going to be following some of the rules of indices when we start solving. So let me do that real quick. Firstly, if you look at what we have here from this point, now we are looking at the 1 over 2 we have here. And this 1 over 2 is for everything inside what? The brackets. Because if you are looking at what we have in the brackets, everything here, this 1 over 2 what? Covers it. So now I'm going to be breaking everything down. So what I'm going to be having here is that from this place, this 729, I'm going to be separating it from what? My V. You understand? So from this point, I'm going to be having 729 inside the same what? Inside that same root. We are having what? This 1 over 2 to come to this place. You understand? Because it's for the both of them. Then secondly, we are also going to have our V minus 6. You understand? All to the power of what? 1 over what? 2. So let us break it down in this manner, you understand? So from this place, what we are going to be having is that from this place, when you see something like this in indices, it simply means that you are looking for what? The square root. So whenever you see something raised to the power of 1 over 2 in indices, it means what? Square root. So we are going to be looking for the square root of this, which is the square root of this is going to be given to me as the square root of this is going to be given to me as what? 27. So the square root of 729 is 27. Now everything is still here, multiplied by what? My V. Now whenever you see something like this in indices, you just say this multiplied by this, which is going to give me what? My minus 6. Then divide by 2 is going to give me what? My minus what? 3. You understand? So from these points, what we are going to be doing is that, again, this cube root that is here is for what? Everything. This cube root that is here is for what? Everything that is here. So what we are going to be doing here is that from these points, this 27 is going to be what? Carrying what? The cube root. Then the same thing applies to what? My V. My V is also going to be what? Carrying what? The cube root. So my V raised to the power of what? Minus what? 3. So when you see something like this in indices, it simply means 1 over V raised to the power of what? 3. So now let's simplify everything and get the final answer for this. So when we're talking about the cube root of 27, it simply means 3 numbers that you are going to times 3 the same numbers that will give you what? 27. And looking at this 27, for you to get 27, you need to say 3 times 3 times what? 3. So my 3 times 3 times 3 is 27. So the cube root of 27 is what? 3 multiplied by what? The cube root of 1 is what? 1, because 1 times 1 times 1 is what? 1. All over what? The cube root of V raised to the power of 3, which is V times V times V, is what? V. You understand? So from this place, my answer for this question is going to be 3 times 1, 3, all over what? V. As my what? Final answer. So now, we have simplified these indices, and this is the final answer we have gotten for what? It. So if you have any question pertaining this, You can drop it down in the comment section. So let's go. So now, let me talk about the second question. We're talking about the second question. So to avoid me cleaning what you haven't written, you just need to take a jotter and start putting what we are doing down, you understand? So we just take a jotter and start putting it down. If you're just joining us now, just drop the location where you are watching from, you understand? So now, the second question says, express 8 minus root of 18 over root of 2 in terms of a plus b root of 2. So that's my second question. So the question says express 8 minus root of 18 all over root of 2 in terms of what? A plus b root of 2. So let's forget the grammar they are saying here. What they're trying to tell us is that we should solve this in such a way that after solving, what we are going to be getting as the answer is going to be what? Something of this sort. You understand? So now this question is gotten from what? Sort. So these are to solve, simplify what? Sort. So let's do this real quick. So the first thing you are going to be doing is that, first of all, you look at the roots and what? Try to what? Break them down. You understand? So now if you look at this root of 18 here, it can be broken down in sort. And what you are going to be doing to break this root of 18 down is that you're looking for what? 2 numbers. Those 2 numbers you are looking for, one of them should be a perfect square, in the sense that one of those numbers, you can get what? A square root for them. So now let's do it. So we're going to be having 8 minus root of what? 9 times 2 all over what? Root of what? 2. Hope I'm not confusing you. What I did here is what? Get 2 numbers that can what? Give me 18, and one of them should be what? A perfect square. And that's what I've gotten, which is 9. So from this place, I'm going to be having my 8 minus what? My root of 9 is what? 3. Root of what? 2. The reason why I'm putting my root of 2 here is because of I cannot get a standard square root for what? This, without getting a decimal number, you understand? All over what? I have what? My root of 2 here. Now, should we leave our answer this way? No. So whenever you are solving in sort, you just need to know that your answer cannot have its denominator something that have what? A root. That the denominator is not going to what? They having a root. So since you cannot leave the denominator with a root, we have another thing we do in sort, which is called rationalization of what? Sort. So we are going to be what? Rationalizing this sort, and which simply means that we are going to be using this denominator to multiply the numerator and what? The denominator. Am I communicating? So now, let's go. So from this place, I'm going to be using what? Root of 2 and what? Root of 2. Now, what we are going to be getting from this point is that we are going to be using this to multiply this and this to multiply what? This. So I will take another trick in sort. What happens in sort is that numbers can multiply numbers, roots can multiply roots whenever you want to open the multiply. So now this is what we are going to be doing. As this, we are having root of what? 2 here. It's having what? An invisible 1. You understand? So we are going to say this multiplied by this, which is going to be 8 times 1, which is 8. Now, root of what? 2. You understand me? Now from this point, I will say what? My 1 times this, which is 1 times minus 3, is going to give me what? Minus 3. Root of 2 times root of 2 is going to give me 2. Ow. Now you might be confused saying root of 2 times root of 2 is giving me 2. Ow. Now I want to show you that using the indices we solved previously. So now when we're talking about root of 2, we're talking about root of 2 times what? Root of what? 2. What it simply means is that root of 2 in indices means 2 raised to the power of what? 1 over 2. And this one, the same thing means what? 2 raised to the power of what? 1 over 2. So if you follow the rule of indices, it says that whenever you have an equal base, you pick one, and whenever you have a multiplication, you add what? The power. So let's do that. So we are having 2 raised to the power of what? 1 over 2 plus what? 1 over 2. So 1 over 2 is half. So half plus half is going to give what? 1. So it's going to be 2 raised to the power of what? 1, which is the same thing as what? 2. So you can now understand that root of 2 times root of 2 is 2. Root of 3 times root of 3 is 3. You understand? So let's go. So from this place, I'm still going to be doing the same thing. Root of 2 times root of 2 is going to give me what? 2. Now, since I've gotten to this point, what I'm going to be doing to finish up, let me just wipe this place so I can write up. So, from this point, what I'm going to be doing is that I'm going to be having my 8 root of 2 minus what? This time this is going to give me minus 6. Now, I'm having what? One denominator. So I'm going to be sharing this denominator for the both of them. So I'm going to be putting 2 here and what? 2 here. The both of them are going to be carrying each of the denominator. So from this point, I'm going to be having 8 divided by 2, which is what? 4. Then I'm having what? My root of what? 2. 6 divided by 2 is going to give me what? 3. So as simple as that, we are done solving. So now let's look at what was given to us. They say we should express it in terms of what? A plus b root of what? 2. And that simply means that when we finish solving, it should be in this format. And if you look at what we have here, we have 4 root of 2, b root of 2. So this root of 2 is this root of 2. This 4 is this b. And this minus 3 is what? A. So we are finished solving for this, and this is your answer for this question particularly. You understand me? So now, I hope you guys can hear and understand what I'm saying. So we are going to be going to the third question. So let me bring out the third question. So if you have watched to this point, you would like to share it to your friends that would like to watch this video also, so that they can join you on the live and learn something today. You understand? So this question, we're going to be taking it from what? Matrix. You understand? I told you I'm going to be picking combination of different topics today. So let's go. It's going to be fun. So now, the question says, find y minus inverse, that's y inverse, if the y itself is equals to 2, 3, 4, and 1. So that's what my question says. My question says what? I should find what? My y inverse if my y is equals to what? 2, 3, 4, and 1. So now this has to solve for inverse when you have something of this sort. Firstly, what you are going to be doing is that you will find what? The determinant. And let us find the determinant of the matrix. So the way you are finding the determinant of a matrix is that you are going to say this multiplied by this, which is going to give me 2. Then you subtract this multiplied by this, which is going to give me 12. You understand? So I'm going to be having 2 minus 12, which my 2 minus 12 is going to be giving me what? Minus what? 10. It's going to be giving me what? Minus what? 10. You understand? So now from this place, I've gotten what? My what? My determinant. I've gotten what? My determinant. So the next thing I'm going to be doing from here is that from this point, I'm going to be bringing down what we have here. But I'm going to be doing some switching. Let me explain again. What I said is that if you are asked to find y inverse of a matrix, and this is the matrix, what you are doing is that you find the determinant first. And what I did is that I said my 2 times what? My 1, which gave me 2. Then I said my 3 times 4, which gave me what? 12. So I did the subtraction. 2 minus 12 is going to give me minus 10. So what you are going to be doing here, you see 1 over what? The determinant. So that's 1 over what? My determinant, which is what? Minus 10. Then you open the bracket of what? This particular matrix. Then what you are going to be doing is to what? Switch these 2. So I'm bringing 1 here, then switching 2 to this side. Then the other thing you are going to be doing is what? Adding negative to these other ones. That's all. You have gotten what? The inverse of this matrix. I'll repeat what I said. From beginning, I was asked to find the inverse of this matrix, which is y is equals to 2, 4, 3, and 1. Then what I did, I find the determinants. And I told you how to find the determinants is that you're going to be doing this multiplied by this minus this multiplied by this. So I did 2 times 1, it gave me 2. Then 3 times 4, it gave me what? 12. You understand? So 2 minus 12 equals to what? Minus 10. You understand? So from this place, what you're going to be doing to get the inverse is that you're going to be saying 1 over what? The determinant, which is 1 over what? Minus 10. in the brackets, what I'm doing is to switch this to this point. So 1 is coming here, 2 is coming here. Then I'm adding a what? A negative to this and this. So that's how to solve the third question. So let's do a quick recap. We have solved the question on indices, we have solved question on sort, and we have also solved question on what? Matrices. So now we're going to what? The fourth one. I hope you're following, and I hope you have been understanding and getting value from what we are doing. Understand? So let's go. I want to believe we can see what I'm writing. Understand? So let's continue. The fourth question we have here says, find Z1 over Z2 if Z1 is equals to 2 minus 4i and Z2 is equals to 6 plus 7i. So the question says, find Z1 over Z2 if Z1 is equals to 2 minus 4i and Z2 is equals to 6 plus 7i. So whenever you see a question like this in mathematics, you're hearing I like this. You are seeing this I. This I is called an imaginary number in mathematics. And an imaginary number comes when you have what? A complex number. Now a complex number contains what? A real number and what? An imaginary part. Now the real number is just the normal number, more like a constant. You understand? Then my imaginary part is the combination of the coefficient of the imaginary number and the imaginary number itself. So the imaginary number is I, and this I was gotten because when you are asked to find the square root of negative numbers, it seems like finding the square root of negative numbers are impossible. You understand? So instead of you looking for the square root of a negative number, so it was not denoted with what? I, for you to find the square root of what? Minus 1. You understand? As an imaginary number. So we are going to be solving this because what they just say is that we have our Z1 and our Z2 given. So they are trying to tell us that we should divide this Z1 with this. You understand? So that's what they are trying to tell us to do. So what we are going to be doing here is that from this point, let me make this place more light enough. So from this place, we are going to bring in what? Our Z1, which is what? 2 minus 4i. You understand? All over what? My Z2, which is 6 plus what? 7i. Now, these are the two numbers that I'm bringing what? Out. These are the two numbers that I'm bringing what? Out. So the next thing I'm going to be doing here is that from this point, let's take a quick look at this. Now there's something we call conjugates in what? In complex number. There's something we call what? Conjugate in complex number. And so this conjugate is what? Changing the sign in what? A complex number. It do happen in sorts also. But you understand? But we are going to be using it here. So the conjugate of this denominator is changing this positive sign here to what? A negative sign. Hope I'm not confusing you. Forget my grammars. So it's just changing this sign here to what? A negative sign. So if I change this sign to a negative sign, I'm going to be doing it the same way I did sort. If you remember what we did in sort, we did what? Rationalization. And what is that rationalization of sort? It simply means that you should use this to multiply up and down. So what we are going to be using to multiply the up and down is what? The conjugate. So this is the conjugate. So the conjugate is what? 6 minus what? 7i over 6 minus what? 7i. You understand now? So now, what we are going to be doing is to use this to multiply this to multiply this. So whenever you see something like this, a normal expansion in mathematics, whenever you see something like this, you want to expand it. It simply means you should use this first value to what? Multiply everything here. They use the second value to also multiply everything here. You understand what I'm doing? Then the same thing applies to this, the same thing applies to what? The other. You understand? So now, firstly, when you are solving this kind of question in complex number, note this. I square is what you should note. And I square is equal to what? Minus 1. So just keep it to one side. We are going to be using this guy here. I square is going to be equal to minus 1. We are going to be inputting it right here. So now let's do what I said. So I'm going to be saying 2 multiplied by everything here. 6 minus 7i plus 4i. Okay, this is negative I. Minus 4i times what? 6 minus what? 7i. I hope you're following, right? From this place, I'm going to be saying 6 over 6 minus 7i plus 7i bracket 6 minus what? 7i. So I just use this to expand everything here. Use this to what? The same thing here. This times everything here. This times what? Everything here. So now let's continue from this point. Now I want to give you one advice whenever you are solving complex number. Make sure your eyes are dotted. The moment you begin to make mistake is when you mistakenly miss this eye, and because this eye will just look like 1. It's not like you are copying mine. You might decide to write your straight. So it might just look like 1 and you make that mistake of solving. So make sure you are dotting it very well. You understand? So let's go. So from this point, we are going to be saying this times this, which is going to give me my 12 minus this time this is going to give me 14i. This time this is going to give me minus 24i. Then minus minus is going to give me plus. This time this is going to give me 28. I times I is going to give me I squared. You understand? All over. This time this is going to give me 36. This time this is going to give me... Now, let me tell you something. Whenever you see something of this sort, when you finish solving, what you are going to be having is that at this down part, you are going to be having just a normal whole number. You understand? Whenever you are timesing the positive one and the negative one, the same value, positive and negative, you must get a what? A normal whole number. You understand? So let's do that. So now we're talking about this time, this is going to give me minus 42i. Then this time this is going to give me minus 42, plus 42i. So minus times plus is going to give me minus. This time this is going to give me 49. Then I'm having what? My I squared, because I times I is going to give me I squared. So now, permit me to clean this part so I can continue from here. So I'm cleaning this. 38i plus 28. Now, remember I told you from the onset that this I square here is going to be what? Minus 1. If you remember, I said I square is equal to what? Minus 1. So anywhere we see I square here, let's put what? Minus 1. So bracket minus 1 all over 36 minus 42i plus 32i is going to what? Cancel out, because it's positive and negative. So I'm left with what? Minus what? 49. My I square is now what? Minus 1. We are moving. So now let's go. So I believe you understand till this point. You understand? Just a step-by-step procedure that you just need to follow. So that's why I say you just need to keep jotting so you can use it for reference. You understand? So from this point, I'm going to be having my 12 minus 38i plus minus is going to give me minus 28 times 1 is going to give me 28 all over 36 minus plus this plus this is going to give me what? 49. So now, from this point, let's continue. So what you are going to be having here is that this can only add to this. So whenever you're solving in mathematics, complex number per se, this can only add to this. This is going to stand on its own. You understand? It's a different category. So 12 minus 28 is what we are doing here. So 12 minus 28 is what? 12 minus 28 is going to give me what? By what? Minus 16. You understand? I'm going to be having what? Minus 16 minus 38i. You understand? All over this plus this. Now let's add it manually. 26 plus what? 49. This plus this is going to give me 5. I'll take 1 here and I'm getting what? 85. So we are getting to what? The final answer. So that's the final answer, but answers can be expressed in different way. Answers can be expressed in different way. You understand? So you can see something like this. Maybe you can write it in this form. Maybe 1 over 85 in the bracket minus 6 minus 38i. They are all saying the same thing. You understand? They are what? All saying the same thing. So that's how to solve a question like this on complex number. So the quick tip you just need to know is that whenever you see any question on complex number that regards division, you are just going to be what? Using the conjugate of the denominator to multiply both the numerator and the denominator, and that process is called what? Rationalization. And what I say conjugate simply means is that you're just going to be what? Switching what? The signs. If it's negative, change it to what? Positive. If it's positive, change it to what? Negative. So that's how to solve questions like this on complex number. So a quick review on the topics we are going through. The first one went through indices. Second one we did sort. The third one we did matrices. The fourth one we did complex number. So the last one we are going to be taking here is what? Binomial theory. Mathematical induction. So we're going to be taking the last question from what? Our mathematical induction. So let me wipe the board and let's dive into it. So let's dive into the question here. So find the value. Find the value of 1 square plus 2 square plus plus 10 square. So when you are asked to solve something like this, in what? When you're asked to solve something like this in what? Mathematical induction. So there are some things, okay, let me just explain the topic per se. Mathematical induction just simply means you proving mathematical statements, if they are true or if they are what? Not true. So that's just what the mathematical induction focus more on. But what we are given here is that they want us to what? Find the summation of what? These squares. And I'm going to be giving you the formula. So what we are going to be using there as the formula is 1 over 6. Now, I'm going to be having an n here. Then I'm going to be having n plus 1, 2n plus 1. So that's the formula we are using here. So for me to get this per se, I'm going to be applying what? This formula. This is the formula for finding the square, the summation of square of what? N natural numbers. You understand? So it's just like when you're finding summation of squares in mathematical induction, this is the formula you are what? Using. There's another formula for finding summation, addition of just normal plain numbers. There's another formula for adding cube. You understand? But we are talking about square here, so let's focus more on what? The squares. So now, from this point, I'm going to be having what? My n here is what? This man here. So my n is what? The last man at the back. You understand? But there are sometimes you need to consider the first number. But at this point, or particularly because it's starting from 1, so we are going to be considering what? The last number. So our n here is what? 10. So from here, I'm going to be having 1 over 6. Now, my n what is what? 10, right? Then in the bracket again, I have what? 10 plus 1, right? In the bracket again, I have 2 times what? 10 plus 1. So I'm just applying the formula, you understand? So from this place, I'm having 1 over 6, my 10. 10 plus 1 is going to give me 11. 2 times 10 is going to give me 20. 20 plus 1 is going to give me what? 21. So now, without wasting time, let's do something here. If 3 go here, I'm going to be having 2. So if I divide here with 3, I'm going to be having 2. If I divide here with 3, I'm going to be having 7. Right? And the same thing applies. So let me just write everything down. So I have 10 over 2 times 11 times 7. So let's just break it down again. 10 divided by 2 is going to give me what? 5. Then 5 multiplied by 11 times 7. 5 multiplied by 11 is what? 55. 55 times 7. Let's do that manually here. So 55 multiplied by what? 7. 7 times 5 is 35. I'll add my 5 here, then I'll take 3. This time this is also what? 35. So this I'm going to be having what? 38. So the answer for this is what? 385. So now what we are just trying to tell you is that when you add 1 square plus 2 square plus 3 square plus 4 square till you get to 10 square, you are going to be getting what? 385. So these are all the questions that we are going to be solving today. So I would like you to drop your questions concerning this and other questions you would like me to solve. You understand? So you're going to be dropping those questions for me. Then on our next live, we are going to be going through those questions one after the other again. So firstly, we did what? Indices. And indices is just talking about exponents, it's just talking about powers of numbers. And it's one of the most simplest topic per se in mathematics also. So we also talked about how to express sorts. That was how to simplify sort. So I told you that sort is all about square roots, solving stuff that have what? Square roots. Let me just use that English to make it easier. So we solved the question on sort. Then we went to what? Inverse of a matrix. I gave you the tips on how to solve it. We did that. We went further to what? Complex number. And lastly, we are then in what? Mathematical induction. So at least we have covered questions from 5 different topics per se. And I believe you understand little of what I've been teaching today. And thank you very much for joining us in today's live. Thank you very much for your time. Thank you very much for being with us till the end of today's live. What is going to be doing now is to what? Share the live. I'm still going to be posting this video in the channel, so you are still going to be seeing everything, recap of everything. So I'm still going to be posting this in what? The channel. So what I want you to do is to give me a thumbs up if you have gotten value from what I've been teaching today. Just give me a thumbs up. Drop a comment down in the comment section, the location of where you're watching from. So we'll see you on our next live, where I'm going to be solving those questions that you have to drop in the comment section. See you in the next one. This is Azure Mentors, and I remain inspired. See you guys.